Azam, new background.
Background.
Okay, so I asked last time for you to read on something. What did I ask you to read on? Remember? Siapa remember?
I'm gonna stay quiet for now.
Electron.
Electron. Okay, what is an
Holes.
electron?
A negative charge particles.
A negatively charged particle. Okay, what is a hole? What is a
Medium.
hole? Huh?
Hole.
Oh,
Hang balik tak jawab lagi kat awak. Kalau dia dah jawab, beritahu lah.
Ajak aja.
So, what is a hole? Awak cari ke tak ni?
Holes is the lack of electrons.
Hole is lack of electron.
Ah.
What is proton?
Proton positively charged.
Faiz, awak boleh jawab juga. Semua ni.
Oh, okay.
Ha? What is a proton?
Positively charged.
positive.
Positive what? I cannot
Atomic
hear you.
particle.
You need to say it clearly. What is a proton? What is a
Positively
proton?
charged particle.
Positively charged particle. What's the difference between hole and proton?
Holes doesn't have charge.
Okay, who agrees with Aiman? Hole doesn't have charge.
Hole, the absence of an electron.
Yes, I'm asking my question. Who agrees? You agree or you disagree with Aiman? Hole doesn't have charge. Who agree? You only have two choice. Agree or don't agree. So which one do you? Everybody answer. You agree or you disagree with that statement? Hole doesn't have charge. Okay, who wants to start first? Semua orang cakap kita ada 5 je pun. Kawan awak Hambali tak jawab lagi. Solihin pun ada. Saya pun tak masukkan dia. Kenapa dia orang lambat?
Agree, madam.
Huh?
Agree.
Azam agree. Okay, Najwa? Nanti saya akan tanya kenapa awak agree or disagree. So when you say something, think. Jangan lama sangat think. Cepat. Sepatutnya awak dah baca ni. Najwa. Ni basic. Okay, ni basic bukan first year first year engineering. Masa SPM lagi. So kita ni pergi belakang dah ni. Pergi belakang-belakang. Kalau belakang pun tak settle, kena belakang mungkin masuk tadika lepas ni. Kalau kita tak settle lah benda basic-basic ni. Najwa, you agree or disagree? Cepat.
Disagree. Anyway.
Lambatnya fikir sepatutnya awak dah.
Agree.
Najwa
Okay.
agree. Nadira? Cepat.
Agree. So both positive.
Aiman kata tak ada charge. Awak boleh tak Aiman cakap?
No, disagree.
Kenapa lah? Ya Allah. So okay. Concentrate in the class. Okay. Aiman kata hole tak ada charge. So kita agree ke tak? Betul kan Aiman? Awak kata macam tu?
Betul.
So
Disagree sebab hole ada positive charge.
Aina disagree. So kita ada percanggahan pendapat di sini. Faiz?
Disagree. Also.
Okay. Why you agree, Najwa? Saya nak admit dia orang ni, so saya nak agree dia kenapa mereka lambat. Okay. Najwa?
Madam sebenarnya disagree. Kita jawab salah.
Macam mana ni? Pening ni ke saya. Okay, disagree pula. So, ni agree dengan disagree pun boleh ni, okay? So, siapa agree tadi? Azam. Ambali, why you late?
I forget the class time. I thought it around 12 o'clock like that.
Is that an acceptable answer or no? Hambali?
No.
Okay. So next time, if you are late, I will not admit you. Simple as that. Solihin, why are you late? Still connecting to audio. Solihin, why are you late?
I was trying to open Zoom on my laptop, but it have to update the Zoom, so it's kind of late. So I jump back to phone.
Okay, so make sure you update now so that next time you won't be late.
Yeah.
So
I try to open on PC, but you asked me to use the camera, right? But my PC don't have camera, so I don't use PC this time.
okay, so whatever you do, don't come late next time.
Madam, I take back my
You
my
take back.
stand.
Oh, okay. You take back. You say apa? Agree ke disagree? Lepas fikir banyak-banyak pula,
I reread my note back. I think it got charged because opposite waste electron.
So kesian Aiman seorang-seorang. You want to change now, Aiman?
Beza ke hole dengan proton?
Sorry?
Holes dengan proton bukan lain ke macam?
Saya tak tahu. Kalau dia sama, kenapa nama lain?
Itulah.
Itulah. Jawab Azam. Sebab awak dah bertukar tadi tu. So Aiman jawab tu sebab dia rasa patut lain. So awak kata okay, hole has a charge. So what's the difference between proton and hole? Azam.
Proton got excess charge on the valence electron.
Hole? Okay, hole.
Got excess particle on the valence electron.
Wow.
Valence atom.
Okay. Ni first time ni mungkin nuclear physics teori baru ni pun mungkin yang tak pernah dengar ke. Orang lain ada nak tambah? Siapa what? So all of you now answer disagree. So what's the difference between proton and hole? Hambali, is there any difference between a proton and a hole?
I'm not sure because both of them represent the positive charge.
So you need to
I'm
know.
not sure.
Solihin.
Yeah, madam.
What's the difference between proton and a hole? Is it different or no? Is it the same?
I think it's the same, madam. Yeah.
Okay. Faiz, you keleng kepala. So what's
Oh,
your answer?
no, madam.
No pula. Okay.
There we go.
Whole when there's no electron or the electron move away from the proton is in the center of the nucleus of the atom is in the nucleus. But hole is when there is no electron, when the electron jump away, something like that.
Okay. Faiz, you agree?
Yeah. However, I like to put it in my words basically. So proton is like what makes the center of an atom. So basically, so when we hear like helium, we have two protons. However, that proton is located at the center of the helium atom. So proton is at the center, and then we have the electrons circling around the center of the atom. So that is electron. However, the difference between proton and holes is that the proton makes the center of an atom. A hole is what happens when there is absence of electron.
So
from the outermost shell of the atom.
does electron have a mass?
No,
Yes.
it just have charge, but it
Yes.
has no mass.
Yes. Have mass.
Yeah.
So this is fundamental, right? Such interesting. So Faiz kata tak ada mass. So Aiman kata ada mass lah elektron.
9.1 darab 10 kuasa negatif 31.
Yes, it's very, so okay, electron has a mass. Does hole has a mass?
No,
Electron, right?
Oh, Solehin jawab no lah. Kenapa tak ada?
because it's an absence of electron.
What are the two types of carriers that can make up a current in semiconductor? What are the two types of carriers that can make up a current in a semiconductor material?
Electrons and holes.
Electrons and holes. So can you have current due to hole alone?
No.
No.
Sekejap. Sikit kot.
Macam nak tahu sikit ke banyak?
Saya
No.
baca slide.
Because it's a flow of electron. So
They're
So
moving
tak
with
ada
the
lah.
flow.
no.
Okay, brothers and sisters. So we are now in semiconductor device level 3, and as in your first year degree, you learn electronics. They are supposed to clear already this electron holes, what are the currents. So we are basically just revising, and and normally kalau you in SPM, we don't care whether you only know there's a current due to electron, which is apa yang Solihin jawab tadi. What is current, Solihin?
Flow of electron.
Flow of electron, rate of flow of electron. Dia kena ada rate. Okay. So so that's in SPM. Okay, if you go to degree, sebab tu knowledge have levels. Macam awak belajar darjah 1, darjah 2, darjah 3, 4, 5, darjah 6 tu, benda awak tak tahu yang darjah 1. So darjah 6, oh ada rupanya apa nama ni, integration. Darjah 1 awak cuma tahu tambah tolak je, right? So the same as the concept of current. In semiconductor device, there are two types of current that you can have due to two types of carriers. Number one is electron, number two is holes. It means that you can have current just from holes. Okay, that's why kita cerita doping. Oh, now next. What is doping? Saya tak jawab lagi difference between, nanti ingatkan saya difference between hole dengan proton. What is doping? In your own words, what is doping? Apa faham doping tu?
Adding impurities the intrinsic semiconductor material.
What is doping?
Adding impurities to the intrinsic semiconductor material.
Explain.
Explain.
I don't understand.
Intrinsic
Saya
semiconductor material.
saja buat tak faham, nak cakap awak faham ke tak, ke awak hafal, awak tengok. Do you really understand what is doping?
First, need to know about intrinsic semiconductor material, such as silicon, because silicon have 4 outer valence electron. So when it forms together,
Panjang sangat. Just tell me what is doping.
when adding impurities such as phosphorus, boron to the semiconductor silicon to add electrons or holes to the material.
You agree, Najwa? Tak dengar.
Yes. Yes, madam.
Why do we dope? Najwa.
To make the materials more
Matters more.
Like the natural.
Just for fun. We don't need to dope. There's no point of doping. Huh? Why do we dope? Aina jawab.
To increase electron and hole concentration.
Why do you want to increase the electron hole concentration?
For the sake of stability.
Do you agree, Salihin?
For me, doping is to create semiconductor
No,
material.
I ask you, do you agree or disagree with Aina?
I don't really understand what she's saying.
Tanya dia.
The purpose of doping is to add impurities into the semiconductor in order to increase the electron and hole concentration, and it is for the sake of stability.
Yeah, it's kind of something like that.
Oh, so you agree, yeah?
But there's NNP doping, so sometimes we increase, sometimes we decrease, right? NNP doping, NNP
Kita
semiconductor.
decrease apa?
The electron.
Kita decrease elektron. Macam mana kita decrease? Kita decrease elektron Betul ke Hambali, you agree with Salihin? Can we decrease electron?
Decrease as we can.
Yes, you can.
Yes.
How?
Apa panggil? Saya cakap.
Oh, saya pun tak tahu. Cuba cakap.
They are doping with a certain material to make certain material that is rich in hole or electron to make the PON.
Ya, tapi Salihin kata kita boleh decrease. My question very specific. Can we decrease the electron inside during doping? Can or not?
I think it can, because
how?
we replace.
No.
Fikir dulu, I will go back to you. Think. Aizam, do you agree that we can reduce the electron in for doping, when doped?
I think no.
Why?
Because doping is the process we add the impurities.
Okay, so do you agree with Azam, Faiz?
He said that Azam, right? Azam, yeah, I agree with him. It's because we adding more impurities inside basically a fixed number of silicon. So we're actually introducing more electron, but we're also introducing more holes. If we're talking about as a P doping. So technically we cannot decrease the amount of electron. We cannot decrease the amount of electron if we don't decrease the size of the intrinsic semiconductor in the first place. So basically what I was saying that in the doping process, we cannot decrease the number of electron. That's it.
Betul yang tambah-tambah sebab dari betul jadi salah lepas tu. Okay, so one thing about semiconductor device or we in this course is very sensitive to terminology and what statement you put. Slightly different terminology you use, it means something else. So kena careful lah. Maknanya you need to really understand what it means, satu, and then use the right terminology. Otherwise, it can mean something else. So you say, oh, you increase tadi yang statement kedua Faiz tu, I will argue whether it's right or wrong. Okay. Actually, my question is a trick question. Can you reduce or no? So then, in order, dia sebenarnya boleh jawab dua-dua. Kalau dia ada level nak jawab tu lah. So macam kalau level awak mungkin awak kata tak boleh, jawapannya level level basic-basic ni kita biasanya doping is you can only add. Doping, the existing semiconductor semiconductor ni, you add whatever other semiconductor material. Okay, this is a piece of semiconductor material which is intrinsic. What is intrinsic semiconductor? What is an intrinsic semiconductor? You learn this in first year. Saya lupa nak suruh cari tapi patut tahu lah kan.
Silicon, boron.
Apa?
The
Silicon.
pure semiconductor.
Oh, okay. What is
Boron, silicon,
what is
Boron?
extrinsic semiconductor?
or extrinsic.
P type and N type.
Okay. Hambali, okay? You want to answer my questions now?
Implicit.
Apa?
What the question again?
What is the question again?
What is the extrinsic semiconductor?
Implicit.
X.
In ke X?
Extrinsic.
X.
Hambali. Apa extrinsic dengan intrinsic? Oh, dark. Something not right.
And it's
so weird. It doesn't work. Oh no. Kenapa dia jadi hitam je tu? Awak nampak hitam juga kan?
Madam present slide kot. Madam buka biasa. Madam tak present lagi.
Tak, biasanya okey je ni. So saya kena restart aku. Interesting. Kenapa it doesn't work anymore? Kena update.
Madam nak share apa PowerPoint?
Kan saya nak airplay daripada apa nama ni iPad saya ni. Last semester it works fine. So must be something yang kenapa saya nak kena Google pula. Semester saya tak try lagi, so saya tak boleh counting ni, cannot see.
Madam, I cannot access the Google form.
Why?
I don't know. I try to play, but I can. This site cannot be reached.
Notability. Okay, that's it.
Oh, okay. Alright, you can see now, right? So Solihin solve it. Kenapa tak boleh? Hambali, awak boleh access the form?
Yes, I can.
So something wrong with you, Solihin. I don't know, something wrong with your phone, something wrong with your connection or something that you cannot. Semua orang boleh. Okay. Can see mine ni?
Yes.
So we have electron, with a hole, we have proton, we have intrinsic semiconductor, you have extrinsic, semiconductor, we have doping. So this is a basic introduction. What else I asked you to find out band gap?
Band gap. Fermi level tadi.
Okay, so Or before that, what is a semiconductor material?
Insulator with small band gap.
Okay,
No,
Azam
technically it's
jawab
correct.
insulator with small band gap. Okay, interesting. What orang lain nak jawab apa? What is a semiconductor material?
A material that can be either insulator or conductor.
Okay. What is an insulator?
Something that cannot conduct electricity.
Okay. So nama dia pun from the name semiconductor material, it means that it's a material that is a part, is partially insulator, partially conductor. So the beauty of semiconductor material is we can control the material to become more like a conductor or more like an insulator. For example, insulator is just insulator. It cannot conduct electricity. Conductor also is a conductor. You cannot stop it from conducting current. However, a semiconductor material, it is in between. So we can control it to become more like a insulator or more like a conductor by the process we call what?
Doping.
Yes, doping. So the higher the doping, the more it will act like a conductor ke insulator. If you put more doping, it's more like a conductor or insulator.
Conductor.
Conductor lah kan. If you put higher doping, you introduce more free carriers. What is free carriers? What is free carriers?
Whole electron.
Whole electron. What is bound carriers?
First time dengar itu.
Apa Azam?
First time dengar.
First time dengar. Okay.
Yeah, signature.
Okay. I wonder should I tell you ke saya suruh awak scrambling cari lah. Lagi bagus awak cari sendiri lah daripada saya ni. Okay, ni ada antara benda-benda yang kita patut tahu. Free carriers, bound carriers. What is it? Google now. Siapa cuba jawab beritahu. And don't forget we are in semiconductor. Jangan cari free carriers kat topik lain pula. Nanti maksud dia lain. We are in semiconductor device material. Anybody has an answer yet? Najwa?
Carriers.
Najwa? Oh, Najwa. You hear me? So, tengah cari. Jumpa ke tak jumpa ni? Tak jumpa?
Immobilized enzymes.
Apa?
Find immobilized enzymes.
Enzyme? Allah.
Yeah.
Itu
That's
topik
biology,
lain.
isn't it?
So, true. Itu topik lain lah. So, that's why the problem with Google ni, it will go everywhere. So, kadang-kadang it has information tapi terlalu banyak that awak kena filter banyak.
So the keyword immobilize?
Yes, immobilize apa?
Immobilize. Maybe electron or what?
Electron?
Tu apa? Immobilize tu free ke bound?
Bound.
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 So free means?
Mobilize.
And move.
Moving.
Free to move.
Free to move around.
Okay, so bound means it cannot move. So what is carriers? what are the carriers? You have only two type of carriers, electrons and holes. So electron and holes can have two types. It can be free electron and bound electron, and free holes and bound holes. So what's the difference? The free means it's free to move. It can move. Bound means it cannot move. So how does that relate to the atom? Kita pergi atom lah. Do you remember this?
Yes.
Okay. So where's the electron?
On the
Electron
shells.
shells outside.
Electron here.
That's valence electron.
So this is the valence electron. So this is all. Is this electron here? Is the electron here mobile or bound?
Mobile.
Mobile.
Free or bound? Kita guna perkataan free dengan bound lah. Tak pakai mobile lah. So is it free?
Free.
It's free?
Because it at the outer shell.
Yeah, agree.
No, it's not free because it's still in the shell. It's still bounded by the atom.
Oh,
This electron over here is free. Okay, so what do I mean? So ni baru satu atom in one semiconductor material. If you have a I draw the 3D. Okay, this is semiconductor material here. Can you guess how many? Sorry, I heard something. I'm staying alone at home. It's scary. Okay, so if anything happen, I shout. You come here. Okay. All right. So lie here. At least make dua. Okay. Now, what I was saying. Can you see this? It is a 3D semiconductor material. How many atoms in this you think? In this 3D. So let's say this is 1 mm by 1 mm by 1 mm. How many semiconductor atoms? Guess. Is it 10, 20, 100, 1?
10 to the power of 30.
30 what?
30.
Huh?
10 to the power of 30.
What? 10 of 30 what? What's the what? 10 of 30
atom.
what? Huh?
Atom.
Apa? Tak dengar. Atom. Okay, yes. So this is 1 mm. How big is 1 mm? Is it big or small? Very small. Small, right? In this 1 mm by 1 mm, you have 10 to the power of 30. Okay, tak tahu bukan million dah, lebih 1 million 10 to berapa?
Million 6.
6 lah. Ni 30 lah. How many millions of 100 millions or more than 1,000 millions of atom? 1 mm by 1 mm by 1 mm. Okay, so this one, the one that I draw here, yang kat sini ni, this is just one atom, right? So you have 10 to the power of 30 of this atom in a very small 1 mm by 1 mm. So what happens is, okay, so what happens is, so this the middle is the nucleus. Saya draw besar sikit lah nucleus saya. Kita draw dia color. Jom kita color dia best sikit lah. Kita color hitam. So ni nucleus. Then you have the orbit. Okay, ni satu. Lepas tu ada lagi sebelah dia. Then ni baru dua. So you have to draw this 10 to the power 30 times. If I ask you to draw, you never do anything else until the end of semester, right? To draw 10, 10 kali, kecuali you copy paste. Itu pun will take you a long time. So can you imagine in the 1 mm by 1 mm, so you have 10 to and you have many of these. So the electrons are, if you have electrons here, the electrons are is still what do you call it? Is still bound electron. When the electrons are released out here, so kalau saya draw lagi biar nampak jelas sikit, saya draw lagi sini. Okay, so kalau elektron tu so if the electrons are out here in between, so it can move. So because the electron in the orbit cannot move, it's only moving in the orbit. It cannot move throughout the semiconductor. So when I say move, it means that this electron can move from here to here. It can move inside the semiconductor material. If the electrons are inside the inside this what they call it in the orbit, it's actually moving, but moving inside the orbit only, and it's considered not moving. When we say free carriers, it means the carriers that makes up a current. Okay, if you have electron moving in the orbit only, do you have current or no? If you have the electron moving, but it's actually moving, of course this electron will move, right? Inside in this what's my pointer? Pointer, okay, blue. So if there is this electron, you know, this electron here moves, it will move inside the along the orbit. But does it gives out current or not?
No.
Why not?
It's not.
Why not? Answer me. What is current, Aiman?
Rate of moving electron.
Okay, the rate flow of a free carrier, whether it's electron or hole. So I'm asking now, my electron now is moving, but in an orbit. Do we have current or no?
I didn't hear that.
You cannot hear. Do we have current or no when the electrons are moving in the orbit? So yang ni pun move in the orbit. Everything moves in their own orbit. Is there any current?
No.
Why not?
Yeah, it's only moving at the fixed place, not along the material.
So, okay. So if I ask a trick question, and sometimes I like to make a quiz and ask a trick question just to see whether you are thinking or no. And then the answer can have a few answers. It depends on how you think. So I like to ask this. So when you say if you have electrons moving in an orbit, although it's moving, there's no what do you call it? There's no current, because current is actually net charge of perkataan dia net. Kalau if you go and Google what is actually, kalau kita nak betul-betul faham what is a current, it's actually net flow of carriers per unit time. Per unit time. So that there might be a net. Ada bunyi ni daripada siapa?
Balik, is that you?
I don't know siapa ni. Yang tu you can mute yourself if there's some sound, background sound lah. But you can turn it on when I ask you. Okay, apa saya kata tadi? Apa saya kata tadi?
Unit time.
Yeah.
Net flow of carriers per unit. Net means there's a total movement. There's a one net current moving. For example, if I draw, sebab you need to understand the concept of current. Kalau tak faham, then payah awak nak faham benda lain. Ni baru basic current. Kita tak cerita benda-benda lain lagi yang macam-macam jenis current nanti. Lepas ni kita akan belajar macam-macam jenis current rupanya yang akan mengcomplicatkan hidup kita. So macam for this 2D of a semiconductor material, right? So if we have put a positive voltage here, negative voltage here. So what happens? Where does the electron flow? From where to where? Where's the
Negative to
electron?
positive.
Huh?
The opposite of current, so negative to positive.
Right. So the electron will always be, electron is negatively charged. It will always be attracted to go to the positively charged. It will go over here. Okay. So if you have a net flow of electron moving from negative to positive, you have current. But let's say I have electron moving, but the electron are moving everywhere. So, you know, like a random. Will there be current? The electron is still moving, but it's random removing. Is there any current inside the material, semiconductor material?
Depends what is the net flow of the total
Answer yes or
electron.
no. Answer yes or no. Random movement.
Technically, yes. If I have to go.
If I take a semiconductor material here, is there any, okay, imagine this is a silicon, a piece of silicon. Imagine this is a piece of silicon. Is there any electrons moving inside my semiconductor, my silicon here? Now, is there,
So pure silicon, you mean?
Pure silicon intrinsic. No, not make it, let's put it intrinsic. Is there any is the electron moving freely here?
No. Just bound electron.
Aina, what do you think?
If it is pure intrinsic, then there is no free electron.
Oh.
Because it is not yet doped.
Oh. You agree ke, Azam?
I think no.
No what? Hello? Dah stuck ke? Azam? You are stuck. Hambali jawablah. Azam dah stuck lah. Hambali? Oh, Hambali.
No current.
Awak cakap je. Azam tu nanti kita suruh cakap semula.
No current, madam.
Cepat sikit Hambali. Kita tak ada masa ni. Habis kelas ni tak habis syllabus kita nanti.
No current.
You say there's no current?
No.
No, Aina was saying intrinsic, if this intrinsic, there's no current because there's no, it's not doped. You agree with that statement or no, Hambali? Agree ke tak agree? Jawab tu.
Tak agree.
Why?
Because it pure.
Tak dengar.
Because it is a pure semiconductor.
So?
It's stable.
Stable?
Yeah.
Saya pun tak faham kenapa stable tak stable ni. Apa nama ni, tadi pun sebenarnya jawapan stability, for stability tu salah. Sebab tu saya duduk tanya semua orang. You know, I will tell you about me. If I ask more questions, most probably it's wrong. You understand? Kalau saya keep on tanya tu, saya saja nak masukkan awak dalam lubang yang sangat gelap dan awak akan hanyut dalam tu. Dan kalau awak cuba menegakkan benda yang basah, tiba-tiba awak akan sedar awak adalah hanyut dan tenggelam. So, tapi kadang-kadang ada tak betul. Saya akan tanya betul dan saya just nak test betul awak teka ke, awak betul-betul tahu. Susah agak nak tahu. Tapi so, I don't understand about this stability. Kat mana awak baca stability ni? Kenapa awak cerita pasal stability? I think I know because you are.
Covalent.
I think I know because awak confused dengan masa apa chemistry, stability kan, macam benda tu balance for in order to stable you need to be apa ya apa nama ni, do covalent bond with another 4 to become 8 yang tu tak? Is that you're confused with that? Okay, brothers and sisters, yang confused tu chemistry. Kita not doing chemistry, we are doing physics. Okay, so dia lain sikit. Dia adik-beradik tapi dia lain sikit. So tak ada kena dengan stability. Mungkin ada tapi stability yang awak faham tu chemistry. Jadi, so kita kena faham benda betul. Jawapan kepada soalan saya kat sini tadi,
Is there a current inside a non
inside a piece of intrinsic semiconductor. Azam tadi awak dah boleh bercakap dah. Tadi awak lag.
Boleh.
So ada tak current, Azam? Kat sini.
Current, I said no.
Ada, kenapa?
Because teka madam.
Teka. Silalah teka. Tembak tak apa. Sebab apa? Tembak pun kena ada jawapan, kena teka tu kena ada berasas juga. Dia tak ada tembak yang tak berasas. Sebab kita, we are engineers. Okay, let's go basic basic. Kita go basic. Awak saya rasa awak ni semua confused. Saya saja nak mengconfusekan awak sebab saya nak test awak ni semua ni faham ke tak. So kesimpulan saya awak tak faham. Okay, saya rasa lagi ni awak tak tahu apa benda. Bila tanya balik, sekarang ni awak pun confused. Electron hole tu apa benda tak tahu. Sebab tu tak jawab lagi, proton, electron hole tu basic. Lepas ni baru nak cerita current, macam banyak jenis current, kenapa current ada kat situ, kenapa current tu tinggi, rendah, semua we will learn on that. So basically, let's go back to this diagram over here, right? So my question is, when the electrons are moving in the orbit, it's moving, we don't call it a free electron. Free electron is only, as I mentioned, that it will give out current. In order for it to give out current, it must be a net flow. Okay, it means that electron must go from one direction, one point to another point. Okay, so if you have a positive here, negative here, so negative here, positive here, so electron will move this way. So you get current. Similarly, hole also behave similar but opposite of electron. For example, you have a hole over here, you put this negative tadi kan, it is positively charged, hole will move to the negative side and we have net flow of carriers. Carriers ni kalau hole jadi hole lah, you have net flow of hole per unit time, you have current. Okay, so that is the one that moves is the free carrier. So if you look here, where are the free carriers? The free carriers are here, yang duduk kat luar ni. Yang tak dalam orbit. Okay, soalan saya, kenapa elektron itu boleh duduk kat luar? Anybody can answer? First time madam dalam hayat saya dengar elektron duduk kat luar. Ke macam mana?
Sebab tak ada holes, madam.
Macam mana?
Tak ada holes.
Tak ada hole? Macam mana? Tak faham.
Maksudnya dia tak ada tempat nak gabung lah macam tu.
Tak
Band
faham?
gap, madam.
Tak faham. Tolong explain dalam satu ayat ke, awak ni satu kataan, mana saya nak faham. Kenapa elektron ni boleh duduk kat sini? Dekat luar? How?
Because it doesn't have enough energy to replace the other electron.
Because it doesn't have enough energy to
replace the electron in the shell. So it's not replace as it to flow something like that. Band gap, madam, is because of band gap.
Okay, since I brought up the issue, the band gap, what is band gap?
Is it the difference between the top of valence band and conducting band?
Siapa cakap ni? Nampak. Who's talking?
Me.
Ni tu siapa? Saya punya Zoom ni.
Salihin.
You know dalam Islam macam mana alang-alang tu saya mention pasal ni dalam Islam kalau pergi kat rumah ada hadis Nabi kalau pergi kat rumah orang ke bilik kawan awak dekat dekat mahallah awak ketuk bilik kawan awak kalau awak tanya siapa ni awak jawab apa? Saya. You know there's a hadith saying that when somebody asks you who you are, you cannot mention in terms of saya, you have to mention your name, and that's from the sunnah. So why? Sebab Islam ni sangat menjaga siapa saya tu, macam geram kita dah macam sibuk siapa saya, yelah saya, takkanlah awak pula, you know. You understand? So when people ask you always say saya Faiz, saya Aiman, saya Salihin, saya apa, you know. Tu kalau awak ketuk pintu orang yang makna sunnahnya kena beritahu nama. Instead tak boleh kata siapa saya madam, tak boleh. Sunnahnya you have to tell your name. So Salihin kata apa tadi?
I think it's because of the band gap, because the free electron doesn't have the enough energy. As
What
the
is
band
band
gap
gap? What is band gap?
represent the minimum energy required to extract the electron.
How do you get band gap? How do you get a band gap from here?
Between the proton and the electron, the nucleus has the attraction, right? The nucleus attract the electron. Okay, and to pecahkan the bond, other electron must have enough energy.
Where's the band gap here? Where's the band gap here? Is there a band gap here? Anybody can answer? Okay, go and Google this Pauli exclusion principle. Okay, go and Google it, go watch some videos, and from this Pauli exclusion principle, it comes up with the principle that in the end, explains how do you get band gap from here. Okay, from atom, you have, this is only 4. Imagine in 1 millimeter by 1 millimeter by 1 millimeter, there are 10 to the power 30 atoms. So these atoms is it very close together? No. In very small area, you have 10 to the power 30 atoms. So is very packed, right? Yes or no? Yes. It's very small and it's also very packed. So what happens is, this I'm explaining in a very simple term, this Pauli exclusion principle. But I want you to go and Google and find out what is it. Okay. So, but the easiest way to understand is Pauli comes out with the principle says that when you have many atoms together, this orbit here will interact with the orbit over here. Okay, and this will interact with the orbit here. So since they are very close, everything will be interacting, okay, because it's very close and packed. But Pauli exclusion principle states in one energy level, there cannot be more than one electron. Okay, this is the principle theory dia. Dia kata in one energy level, so what is energy level? Saya suruh cari kan. What is energy level?
Radius of orbit of the electrons.
Apa?
Radius of orbit of the electrons.
Again, can you repeat that again? Tak dengar. Terus tak nampak muka pula tu. Kenapa lagi tak naik? Najwa.
Radius of orbit of electrons.
Radius? Apa?
Radius of the orbit of the electrons.
Radius. Ages sikit.
Radius. Radius.
So energy level is a radius. Radius means in centimeter, millimeter, right? What's the unit of? Okay. Anybody else? Thank you for trying. Dekat dah, tapi tak tepat. Online? Kalau tak faham tahu, anytime during the class, if you don't understand, ask. Because after this, we're going to more complicated. If the basics you don't understand, lepas ni inna lillahi wa inna ilaihi raji'un. You won't understand the rest of it if you don't understand the basics. So make sure you understand. Jangan hafal, understand. If you think something tak clear, tanya. So, what's energy level? Who else want to answer?
Energy needed to release the electron.
Energy needed to release the electron. No. What else? Who else? Faiz?
Yeah, I tried to find the definition, but I don't understand actually. Quantum mechanical system of particle that is bound, that is confined spatially. So based on what Najwa said, is that it's like a relative distance between the electron and the center of the atom. That's what I visualize. But
Okay.
No.
The answer is no. Okay. You know what's energy, right? Energy level just means that you need to imagine electron and holes are like, it's a particle. So it's like it has mass, the other berat. It has mass and it can move. So it needs, kalau kita, we on earth, we need to sit on something, right? We kalau kita duduk kat atas, we are standing or sitting on the maknanya lab, apa kata dia tu,
we occupy space.
Base tu, kita ada tempat yang kalau tidak kita jatuh, right? If there's no level tu, tingkat tu kita akan jatuh. So and then kalau kita dekat ground floor, the earth is actually the base. So kita boleh duduk kat situ tak jatuh. The same. So energy level is like a state where the electron holes need to stay. Kalau tak ada energy level ni, it cannot be there. The electron and holes need to be at an energy state or energy level to be able to stay there. So energy level ni dia banyak level lah. So energy can from high, for example 1 MeV, 2 MeV, 3 MeV. So each one has macam tingkat 1, tingkat 2, tingkat 3, but each level tu is an energy. We define or we can characterize it with the energy. So, but electron and hole cannot just stay anywhere. It has to sit at an energy level. Okay, it cannot just be in every electron and hole have to be at energy level, or sometimes we call it energy state. Now, memang macam tu, dia tak boleh duduk tak ada energy. Every electron hole must have an energy. So this energy is where kau nak nampak visually, physically, kita nak visual is where they stay lah. So jadi bila let's look back at this drawing. So here all these electrons at the outer valence band tu is all have an energy level already. Can stay there nicely. However, when they are very packed, they are very close by, this energy level, okay, energy level ni, color line lah. Energy level this and this energy level sama, sebab dia how many distance from the, because it's the same atom. For if this silicon, this is silicon, so the energy level is the same. But Pauli exclusion principle says an electron, one energy level can only sustain one carrier. So it means that because of that, because of this, a lot of 10, can you imagine you have this 10 to power of 30 of this outer level crammed together. So what happens is, because of this Pauli exclusion principle, Nanti awak boleh tengoklah video dia macam ini. Dia draw tu macam ini. Ni daripada side view. Yang ni top view. This one is the top view. This is the side view that I'm drawing. So ni yang tengah ni nucleus. Dia macam gitu kan. So setiap ni ada banyak level. Ni semua energy level dia daripada nucleus tu. So yang kat atas ni dia akan bertindih. So what happens because of this Pauli exclusion principle, it stays, then dia akan split dua. Which means that you will have two band. One is called the conduction band. Bawah ni we call it the valence band. So what is it actually? What is it actually? So all this when the whole thing here, energy level is interacting, but it cannot the electron has to be in one electron in one energy state. So it will split to become like this, and the conduction band actually consists of many 10 to the power of 30 of energy level. So setiap satu you will have electrons stay here. And here also you have many energy state. So this is conduction, this is energy band diagram, and this axis here is energy. Okay, and the difference between the top of valence band to the minimum of conduction band is called the band gap. Okay, so what happens is, because Pauli exclusion principle said one energy level cannot have more than electron, the whole atom here will become split here. It will split, and in the end, to make our life easier, we draw it like this. It becomes energy band diagram, whereby it's split into two bands. Each band have multiple level of energy states. So you have conduction band and valence band. So now, if any question up to here, ada soalan? Ada soalan tak sebelum saya continue? Tak ada. Senyap.
So there's a multiple level of energy states, right, in each band, conduction and valence.
Yes.
So what about the gap?
So see, so the gap is where there's no energy state or energy level. So remember I said that electron hole must have energy level in order to be there, right?
Yeah.
So in the band
Otherwise
gap
it
here,
will-
there's no energy level. Can electron or hole be there?
No. So that's why it's called forbidden.
Yes, that's
Gap.
why it's called forbidden band gap.
Mm.
Ideally, electron holes cannot be there. But brothers and sisters, life is not ideal. Life is always not ideal. Even semiconductor device. So later we will learn the real of semiconductor. Ni baru ideal lah. Idealnya kita nak suami handsome, kaya, tinggi, semua benda lah. Tapi in life you don't get all that. Okay, nak isteri yang cantik, cerdik, kaya, puteri raja, semua. But life is not like that. So including everything, including physics, semiconductor also, although ideally, theoretically, there shouldn't be any electrons or holes inside the band gap. But later you will find out that there's ways of introducing energy level inside the band gap. Okay, so ni idea lah, ni baru basic idea. So sekarang ni kalau kita ada elektron, so okay, imagine lah. So sekarang ni macam ni lah. So yang atas ni jadi conduction band. Yang bawah ni akan jadi valence band. Okay. You follow? So atas ni jadi conduction band, yang bawah ni jadi valence band. Soalan saya, dalam valence band ada elektron tak?
Ada.
dalam ni conduction band, ni valence band. So awak kata dalam valence band ada elektron. Siapa kata ada dalam valence band ada elektron? Say raise your hand. Raise your hand guna yang bawah ni boleh tak? Dia ada dia ada
Next one.
yang tu. Boleh tepuk lagi. So raise your hand. Siapa kata dekat valence band ada elektron? So Hambali, Aina, Aiman, Solihin kata tak ada. Solihin?
Macam mana nak raise hand?
Macam mana nak raise hand? Macam
Tanpa
mana?
pun.
Just go to the task at the
Reaction.
bottom. Yeah,
Reaction.
reaction.
Reaction ada clap je.
Reaction. Clap pun tak apalah.
So ada bawah sekali ada raise hand atau lower hand.
Asal ada reaction lah. So
Nak update dulu kot.
boleh buat yes rupanya. Macam mana nak buat yes lah?
Ya, ada yes.
Kenapa saya tak nampak reaction tu? Ke saya tak boleh buat reaction? Kat mana reaction tu? Saya tahu ada tapi kalau saya interesting. Saya punya tak ada reaction. Semua orang ada reaction eh?
Yeah.
Ada madam.
Participant, chat, share screen, record, and then reaction to the rightmost.
Show all hands. Interesting. Sebab saya ni saya tak ada, macam tak logik tak. Tak apalah, itu tak penting. Kita lebih concentrate yang lebih penting. Okay, so jadi semua orang ada tak yang kata dalam valence band tak ada elektron?
Ada.
Ada tak yang kata? Tak ada?
Ada.
Dekat conduction band ada elektron tak?
Ada.
Ada juga. So apa beza elektron dekat valence band dengan elektron dekat conduction band?
Density.
Density. Siapa jawab density tu?
Solihin.
Solihin. Kenapa? Apa awak maksudkan dengan density?
Valence band banyak elektron, conduction band kurang.
Why?
I'm not sure why. Yeah, because the force by nucleus.
Interesting. Can you see my stars?
That was interesting.
Sorry, I was trying to find the reaction. Suddenly, I can even put spotlight here. Oh, interesting. Yeah, how do I put spotlight? Oh, tak boleh pula. Sorry. Okay, kesimpulannya tadi, jawapan saya ialah here are my drawings. Now, what's the difference electron valence and conduction band?
Density.
Density. Mungkin betul. What are the main difference between electron in conduction and valence band? Other than density.
We're going back to the bound and the free carriers.
So
the bound carriers are in valence band where they cannot move well freely. But once the carriers are free to move or becomes free carriers, they move to the conduction band where they can cause and current flow.
Okay, correct. How about hole? Where is the hole? Where are the holes?
Valence.
Hole in the valence band. Do you have hole in the conduction band?
Oh, this is tricky.
Apa Faiz?
I think yes.
Kind of tricky, yeah.
You think yeah, so both have hole. Hole kita biasa bulat.
Yeah.
So what's the difference between hole in conduction and valence band?
Rounded. Rounded is event.
Moving and not moving.
Okay, which one is moving and which one is not moving?
That is rounded.
Where's the free hole? Conduction
The
or
one in
balance?
conduction.
Conduction
The one in
band.
conduction
Conduction
band.
band.
bands.
Ah, who says free holes in conduction band? Say your name now. Who says free hole in conduction band? Say your name now.
Raise my hand.
Ada tak yang kata tadi? Mana tadi? Do you understand my question?
Yeah.
Okay. Awak semua ni.
Madam dah pening.
Apa yang awak pening? Saya tanya free hole ada dekat conduction band. Betul ke salah? Free hole ada di conduction band. Betul ke salah? Siapa kata
Betul.
siapa kata betul, siapa kata salah? Ha. Aina kata?
Betul.
Okay. Azam?
Conduction band, madam.
Free hole in conduction band. Right or wrong?
Right.
Right. Faiz?
I'm gonna go with right also.
Hambali?
Confusing usually.
Right.
Right or wrong?
Right.
Right. Najwa?
Betul, betul.
Huh?
Betul. Yeah, right.
Aiman?
Wrong.
Okay. Solihin?
I don't think so.
Okay. Why
I'm
Aiman
not
say
sure.
wrong? Huh? Aiman, why you say wrong?
I don't know why, but when I read about Fermi level, the
Mhm.
Fermi level of hole is at the bottom, at the valence, and something like that.
Jadi?
So, yeah, I don't understand yet about Fermi level.
Okay. Solihin, why you answer wrong?
Yeah, madam, excuse me, madam. Clear sampai.
Okay, dapat awak beli apa? Tak apa, okay lah. Alright, okay. So,
Speaking of carriers.
Huh?
Speaking of carriers.
Carriers. Okay. Okay, let me see.
Good
Now,
Lord.
okay, brothers and sisters. Okay, I will try to.
No. Receptor ionization receptor correspond to receptor.
Okay. So, now. Okay. Sebelum kita nak habis ni, now I will explain again. Electron holds proton. Electron and hole is a carrier. Okay, there are only two types of carriers inside a semiconductor material. Two types. You have the electron and hole. Carriers means the one that can give out current. If it moves, there's a net movement of the carriers, you will have current. What is proton? Proton cannot move. Proton is in the nucleus. So the difference between a hole and a proton is that proton, proton is a particle inside the nucleus which have a positively charged. It has a positive charge, but and they have a different mass as compared to a hole, and the position of a proton is in the nucleus and it cannot move. Hole is it's an absence of electron with a positive charge. So we consider hole is a carrier, dia macam particle with a mass. It has its own mass. Electron has a mass, hole also has a mass. Hole is heavier compared to electron. They do some experiments and they found that hole is heavier, so lagi berat. So if you supposed to make a current, you will have less current per unit. If the same condition everything, it will have the rate will be less compared to electron because it's heavier. Orang gemuk lari dengan orang ringan lari, gemuk tu lari lambat sikit. So but it has a mass. So the way we treat electron hole in semiconductor is like two different particle that has its own characteristic. Dua-dua ni macam dua particle, walaupun it's absence, tapi it has its own mass and it has its own sifat, characteristic. It's just like electron but opposite. So meaning electron will move from positive to negative, hole will move from negative to positive. Okay, it will go to always the opposite direction. And hole and electrons is always, mostly is always opposite. Remember Allah said in the Quran, everything Allah created with pairs. Everything in the whole entire world, Allah created in pairs. Woman, man, cold, warm, electron, hole. So the pair of electron is actually hole. Proton is another entity. Okay, so in semiconductor device, we don't care about proton. Why? Because proton doesn't move. Anything that doesn't move doesn't bother us. We want something that can give effect, that give out to the current, and optical properties are the one that can move, which is electron and holes. Okay. Intrinsic, extrinsic. Semiconductor device semiconductor material have two types. So if I were to we say semiconductor material have two types, intrinsic and extrinsic. And intrinsic means is yang ni selalu student confused and always confused, especially first year, confused macam raja. I really hope that none of you will confuse in this elective course. Intrinsic semiconductor is a pure semiconductor. Extrinsic semiconductor is an intrinsic semiconductor but being doped, meaning it's the intrinsic tapi doped. So doped with many other material. When we say dope, we say dope with impurities. Why we call it impurities? Because it makes it impure. It makes it, kan intrinsic tadi pure. Pure semiconductor means there's nothing else. If it's a silicon, it's pure silicon. There's no other atoms inside the intrinsic semiconductor. But extrinsic semiconductor, you can have, so this is a piece of intrinsic semiconductor, silicon, okay, pure intrinsic. So if I take this pure intrinsic, I add doping, I add impurities, this same thing, silicon, become extrinsic. And we call it p-dope or n-dope silicon. So that's the difference between intrinsic and extrinsic. Let me ask you, that's silicon, right? What if a gallium arsenide? Gallium arsenide is a type of semiconductor. Is it intrinsic or extrinsic?
Extrinsic.
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 Ada jawab intrinsic tak kat sini? Tak ada orang jawab intrinsic? Azam?
Extrinsic, madam.
So you all are all wrong. Okay. This, if I say this is a gallium arsenide. This can be an intrinsic semiconductor. It's a pure gallium arsenide. So intrinsic semiconductor, yang ni yang student selalu confuse, kata salah, awak semua jawab salah. So confirm my prediction. So intrinsic semiconductor have two types. Semiconductor. So intrinsic semiconductor have two types. We call it the, apa perkataan itu? Single atom. Apa dia ada nama dia? Apa nama dia? Ataupun multiple. Apa nama dia? Sekejap.
Particle.
Huh?
Particle.
What's the name? Huh? Dia ada nama. Kenapa saya boleh lupa pula nama dia ni? Tapi nama tu tak penting, konsep tu yang penting. Macam ni okay. If you look here, silicon, germanium, gallium arsenide, zinc selenide, all are semiconductor material. So they all can be intrinsic. So intrinsic ni, it can be a single atom. Silicon is a single atom. Gallium arsenide is a combination of apa ni? Gallium and arsenic. So that's why semiconductor you have perkataan dia, saya happy lah tak dapat perkataan tu. You have, tak ingat, nanti aku cari ya. Perkataan ni maksudnya yang single atom. For example, silicon here is a semiconductor. Germanium is a semiconductor. But gallium arsenide, in order to become a semiconductor, it must be a combination or compound. Nama dia compound. Compound. Semiconductor. So gallium arsenide is called a compound semiconductor. It can be intrinsic. Because gallium arsenide, it becomes gallium and these two becomes one semiconductor material. So as mentioned before, mana? Zinc selenide is also a semiconductor. Okay, it's also a semiconductor, but it's compound semiconductor. So going back to my drawing just now here, so you have compound semiconductor, and you have, I can't remember the name, semiconductor. So you have two types. So for example, this is called silicon, germanium. Compound is gallium arsenide, aluminium, gallium arsenide, silicon carbide is in compound semiconductor. Yang ni single atom ni, single germanium tu is a single atom semiconductor. So gallium arsenide, so all this can also become extrinsic. If you dope gallium arsenide with another material that will give you excess of electron, it becomes n-type, it can become extrinsic. Silicon carbide also you can dope it to become, what do you call it, n-type or p-type. Okay, so jangan confuse lah. So intrinsic pun dia ada dua jenis. So maknanya they can be compound. Gallium arsenide also intrinsic. Gallium arsenide can be both intrinsic or extrinsic. If you dope the gallium arsenide, it becomes extrinsic. So doping, how do you dope? You add other material. No, you add another material with different numbers of valence electron. So if you have less electron, it becomes, you dope it with a hole. If you have more, because when you have valence electron, you only have electron lah. So if you have excess of electron, become n-type. Become less of the electron, become p-type. Tu je dia punya apa nama ni, story. So just to recap, and free carriers means carriers that can move, which gives rise to the current. So you can have both free electron and free hole, bound electron and bound hole. So going back to this, our energy band diagram over here. Remember the concept of opposites. So electron and hole always opposite. Dia buat benda semua in opposite. So if free electrons, for electrons to be free, it has to be in the conduction band. For electrons to be free, it has to be in conduction band. And if you, in the valence band, is there any electron? Yes. In valence band, you have a lot of electron, but the electron is bound, is immobile. It cannot move, right? It cannot move because there's no free states, empty states. In here, okay, macam mana nak cerita empty state, free state lah. Macam maksudnya, dekat sini ni, you have banyak, can you see banyak energy level, right? But all the energy level are occupied. So setiap level ni being occupied by electron. So you cannot move. Can you imagine a room full of people? Can you move? There's no space to move. So that's what happened in valence band. You have a lot of electron, but the electron is actually bound, cannot move. But in the conduction band, each energy state over here yang biru ni, is many of it is empty state. Meaning, can you imagine a room have many empty spaces? So you can move, right? You can go here, then you move there, you can go there, go here. So that's why electron, when it goes to the conduction band, it can move. So electrons in the conduction band is called free electrons. And to us, the most important are the free carriers. So lepas-lepas ni, in the future, if you say electron saja, without mentioning at the bound of free, we meant it's free. We are talking about free, but we don't really care. Nothing happens in the bound electron. See, for holes is the opposite of electron. Okay, opposite of it, because this the nama dia pun absence of electron lah. So it means that for hole kita draw dia bulat, is the opposite. It means that for hole to be free, it has to be in the valence band. Opposite lah. Hole to be free, it has to be in valence band, and the bound hole will be in the conduction band. So this is bound hole, and this is bound free hole. So the opposite. So empty state for the hole, there in conduction band, there are lots of holes, which are, there's no space for the hole to move anymore, so it becomes bound. But when the hole goes to the valence band, there are a lot of empty states for holes. So tempat duduk electron hole ni tak sama. So in valence band you have lots of free holes, so the holes can move around. So that is the basic concept. Yang ni penting yang kena ingat dan tak boleh tertukar. That free holes are in the conduction band and free electrons are in the conduction band and free holes are in the valence band. Okay, any question? Any question?
Oh, sorry, I'm muted. Yeah, I got one question.
Hmm.
So according to what Madam said earlier, Pauli exclusion principle. So what it means that specifically to electron, you said. So one electron cannot occupy the same energy level as other
sama
electron,
juga.
right?
Hole pun sama.
Hole pun sama.
One energy level can only occupy one hole.
So can one energy level occupied by one electron and one hole? Or is it the electron fill the hole?
No, the energy level for electron and hole are different. We cannot we don't say they're staying in the same energy level. Dia macam kena yang berbeza. Dia tak boleh electron hole duduk kat energy level yang sama.
Okay. So they have to be on the different energy level also.
It can yes, because dia tak boleh duduk sama, dia tak sama, dia tak boleh duduk kursi yang sama, dia kena kursi yang berbeza.
Oh yeah, because electron and hole is like
macam kursi lah.
Because electron and hole is like two different particles, right? So they cannot sit on the same space.
Yes,
cannot. The analogy?
Yes, cannot. Okay. So ni konsep basic yang lepas ni kita akan learn a few more. I want you to go and read. I want you to now next ask me question. Next class, I want to go to the slide. Slide yang awak ada dekat dalam Google Classroom tu. I want you to read daripada slide apa nama ni? Slide ni, periodic table ni. Tak tahu slide nombor berapa. 9 sampailah slide habis slide. Ask me questions. Things that you don't understand. The basic ni basic concept lah. Everything that you don't understand, including Fermi level, semua benda, sedetail-detail benda kat sini, you can ask me questions. Then I will ask you questions so that you will have the basics clear. And apa awak tak faham pada hari ni, jot down and ask me. Jangan confuse lah. Kalau awak confuse, awak akan sakit nanti. So untuk mengelakkan awak confuse, tanya saya soalan. Okay, brothers and sisters, I think that's enough for today lah. Let's end the class. Can we have a brother to recite a doa? Siapa punya turn hari ni? Siapa yang belum? You know who you are? Tak ada balik ni.
Medium.
Okay, Salihin.
Bismillahirrahmanirrahim. Alhamdulillah, wassalatu wassalamu ala alihi wa sahbihi ajma'in. Allahumma inni na'udzubika min hammi wa nazan, wa na'udzubika min al-'ajzi wal kasal, wa na'udzubika min jubni wal bukhl, wa na'udzubika min ghalabati ad-dayn wal faqr. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Sallallahu alaihi Muhammad wa ala alihi wa sahbihi wasallam. Alhamdulillah.
Okay, thank you. See you on Wednesday, Thursday insyaAllah. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you,
Thank you,
madam.
madam.